Okay, so I'm going to give you 3 types of word problems. One type will have kind of 2 separate types, but okay, so this is question one type. So we're going to talk about mixing up water and chemical together, which in chemistry is called a solution, right? When you have 2 things together mixed, it's a solution. Okay, so here is the overall strategy. The chemical that you have divided by the total fluid equals how % strong it is. And the total fluid is when you have the chemical and the water mixed. That's what I'd be talking about with everything in there. Okay. I'm going to draw you a little bit of a visual here. So here's my beaker cup or whatever I have. I have a solution of 20 liters of antifreeze and water. So there's 20 liters of mix. It's mixed. And it's 40% strong. So 40% is antifreeze. So how much antifreeze is in there? If it's 40% of that is antifreeze. So 20, what would I do? How do I get 40%? Times it by 0.4. Does that make sense? 40% equals 8. So as of right now, this mix is 8 antifreeze and 12 of it is water. Okay, we want to put more antifreeze in. We're going to add more. Do I know how much more I want to do? Nope. So I'm going to use a variable. And are you okay if I'm picking A as a variable? I don't know how much I want to add. Okay, here we go. The formula strategy says to do the chemical. So at the start, I had 8, and then I'm adding more. That's the chemical. I had 8 liters of it was chemical, and I'm adding more chemical. The bottom says the total fluid. So how much fluid did I have at the start? 20. But when I was adding chemical, my fluid was also increasing. Right? That 20 is not going to just stay there. It's going to go up, up, up because there's more fluid. I don't care what kind of water or chemical, the fluid is still going up. And I want to end up with 60% strength. So 60 is percent. You can do a 0.6, but I'm going to do 60 over 100 because that's a little bit easier for what I'm going to do. Okay, that's the only new part. The rest is all stuff you know. How do I solve this equation? You have your 2 strategies. Do you want to cross multiply or common denominator drop? Which method would you pick? Cross multiply. So there's my cross multiplication set up. Okay, I'm going to expand the multiplication. So 100 times 8 is 800 plus 100a equals 120. Nope. That's 1200. Gotta put 2 zeros on that. Plus 60a. I'm going to isolate the a's, so I'm going to minus 60a. So I'm isolating the a's. Then I'm going to minus 800. And A equals 10 liters. So you're going to have to add 10 liters of antifreeze to this. Okay? And now it's going to be a 60% mixture. Okay, Jeremy takes 20 minutes to push mow a yard, and then if Carl helps, it takes them 12 minutes. If Carl is working alone, how long would it take him? Okay, so on this, here's the big idea. The time that you worked divided by your rate equals how much job you've done. So, for instance, I'm going to give you just a random example. Let's say it takes you 10 minutes to get your hair done in the morning. That's your rate. That's how long it takes you to do the job. That's a rate. If 3 minutes has surpassed, you have officially finished 3/10 of your hair. Does that make sense? So time was 3, my rate was 10, so now I'm completed 3/10 of my job, my hair. Okay, so let's do a chart. Time, rate, and then we have Jeremy and we have Carl. Okay, a rate is the whole job, by the way. A rate is how long it's taking you to do a whole job. That's what the rate is always. Okay, it takes Jeremy 20 minutes to push mow the yard. Is that the time that Jeremy worked or the rate for Jeremy to do the whole job? That's Jeremy's rate, because that's the whole job, so that's a rate. If Carl helps, it would take them both 12 minutes to do it. So what is that? Is that the time of working, or is that somebody's rate? That's the time that they worked, and they both will work for 12 minutes. Because once Carl helped, they both worked 12 minutes and it was done. If Carl were to work alone, how long would it take him? So I want to know Carl's rate. And I'm just going to use a K, if you're okay with that variable, instead of, you can use X's or whatever, but. Okay, so here we go. Time over rate. So Jeremy will complete 12/20ths of the job. Plus, Carl does 12/8ths of the job. I don't know. And when the job that Carl and the job that Jeremy did were added together, they completed the whole job. So this is what this represents. The job done by Jeremy plus the job done by Carl equals the whole job. Okay, that's the new part. Now solving this, you know how to do it. Cross multiply or common denominator drop. So common denominator. So that's what it will look like, two fractions. And what am I going to have to pick into my denominator? I'm going to need a 20k. That's what I'm going to pick. Okay, now you go through and you say, looking at the first fraction, what did I multiply it by? So I'm going to have to multiply it by a k. If I look at the second fraction, the bottom, the new bottom, what did I multiply by? 20. So I'm going to have 12k plus 240. And what am I going to have to multiply this by? It's really like over 1. So it needs to be 20k over 20k. Because that's how you make a 1, right? The same thing over the same thing. Okay, now we did the common denominator. So remember, we're going to drop, conclude, this top has to equal this top. And then I'm going to isolate k, so minus 12k. And then I'm going to divide to get k alone. So if Carl was going to work all alone, it would take Carl 30 minutes to do the lawn, slower than Jeremy. Okay, you're going to fill up your pool and you're going to use 3 hoses. Hose number 1 takes 10 hours, hose 2 is 12, hose 3 is 18. But if you could use them all at the same time, how long would it take? Okay, so this is the same question, style. Time and rate, we had a hose 1, a hose 2, and a hose 3. Okay, if you were just using the first hose, it would take 10 hours. So what should I do with 10? Is that a time or is that a rate? It's a rate because it's the whole job. 10 hours to do the whole job, that's a rate. If you were to just use the second hose, it would take that hose 12 hours. So that's the rate. And if you were to just use the third hose, it would take 18 hours. Okay, so how long does it take when you use all three? Does this make sense that this would all be the same? So I'm going to call it X. I would normally use a T, but once I start writing T's and plus signs, it gets confusing. So what's the time? And that time is going to be for all of them. Okay, same as last time we did. Time over rate equals the job done. So it's the same strategy in that sense, except for the last time we wanted rate and this time we want the time. Okay, so the first hose does X tenths of the job. The second hose does X twelfths. And the third hose does X 18ths of the job. Together, they do the full job. Okay, now cross multiply or common denominator drop. We got to do common denominator. Okay, the first person to find me actually the lowest common denominator gets a sucker today. Can get me the lowest number that I could get that would work.
180.
Oh, Zach, you didn't even give people a chance. 180 is the number. Okay, 180 is the lowest number. If you couldn't figure that out, it's okay to go bigger on this one, like 10 times 12 times 18. I could have picked that. It would have been fine. You would have got there. Okay, ready? Look at the 10, look at the 180. What did you do? Times 18. So 18x now. What do you have to do to 12 to turn it into 180? Times it by 15. So 15x. What are you going to have to do 18 to turn it into 180? Times it by 10. Okay, and then on the other side, you can just think, how do I write 1? The same thing over the same thing. So I need a 180 over a 180 to make 1. Okay, so that's the common denominator. So now we get to do the drop. So this top equals that top. How many x's is that once I put them? I can just go all together here. 43x. Equals 180. So divide by 43. X equals 4.19 hours to fill the pool if all three of them are going at the same time, assuming your water pressure is okay and whatever, all the variables. Okay, last type. I think I'm going to leave the other two for today. So this will be the last one I'm going to do today. This one is having to do with velocity, distance, time. So let's talk about the velocity in your car. What's the speedometer in your car? Kilometers per hour, right? So that's how I always remember it. I don't remember a formula. I just say the velocity, the speed of my car is kilometers per hour. That's how I remember the formula. The speed of my car is kilometers per hour. Now, let's do all the switches. So if I wanted distance, it would be, how do I rearrange that formula? Distance would be that, and time would be, you have to flip-flop time and velocity, right? Distance over velocity. Okay. A boat's going to go upstream in the same time it goes downstream. The time to go upstream in the same time as it's going to go down the stream. Okay, so we're going to work with this formula. Distance over velocity. Time. Distance over velocity. Okay, so this is what I'm going to do. So what's the distance that they're going to go when they go upstream? So a boat travels 9 upstream. The same time it would go 11 downstream. So 11 downstream. And we have the speed of our boat, but we have some current, the water current. Okay, so I don't know the boat speed, so I'm going to go, the velocity is the boat. I don't know the boat speed, the velocity is the boat. What happens to you when you go upstream? Does the current add or subtract to your velocity? It would make you go slower going upstream. And when you go downstream, does it make you go faster or slower? It will go faster, right? The current will make you move faster. It'll push you. So the boat speed minus the water, and here it's the boat speed plus the water. Okay, that's the only new piece. What do you want to do with this? How do you solve this? Cross multiply or common denominator? So this would be a cross multiply. So 9b plus 27. And then the other set should be 11b minus 33. Okay, I'm going to gather the b's together with algebra, so minus 9b. And I'm going to add 33. And divide by 2. So 30 is the boat speed. What are we in? Miles per hour. That's the speed of the boat without the water part of it. So on your test, you might have to find boat or the water speed. Okay? I might do this is the boat. If I did the water, then you would know instead of the B, you would write the number plus minus variable. Right? That's all the only thing you would change. It's the same strategy. Okay? Or you might see this question with not water, but an airplane or a bike, which is headwind, tailwind. Same idea, right? Headwind and the tailwind is the same as upstream, downstream. Okay, so that's the variations on this type of question, but it's almost the same. I feel like on a test once I had maybe this backwards and the person was supposed to solve for the velocity of the water, and then they had a speed that was like negative 150 kilometers per hour. Okay, first of all, a negative speed, that's not good. And I'm trying to make the answers make sense, so I hope your water isn't going 150. Okay? So just being careful on thinking about what it's even actually doing.